All right, since this is the first lab that actually uses the track system, the physics stands, and the Photogate car, I thought I'd show just a slight more detailed setup for this. And there is a diagram on the actual lab that shows you how to set things up. But you'll find the screw and the accessory kit in your box. If you didn't watch that video, check that out. I'll go ahead and keep it low just so I hope this is still on screen. But that comes in from the back side into this screw hole. You know this is the back side, it's got 0 centimeters marked there. You've got the start pin there, and the other end has the car stopper. And just checking, it does look like I'm slightly off screen. I can tilt up, and there, now you can see it. Beautiful. Okay, car, of course that's in your kit. Since this is the first time students will be using this, you can talk to your students about consistency, okay? If you're starting the car and you're just holding it anywhere when you start, you're not gonna have very consistent or accurate results, as we talked about in the first investigation. So that's why there's this little pin here. So anytime that you're starting it, you push that guy up so your car can rest right on the front end of it. So you're starting the exact same placement every time, and it can release to let it go. What I have found to be most impactful or helpful when doing these labs is to give each student a job and role. So I'd have one student who's always in charge of releasing the car, so that way they're consistent with how they're using this and dropping it. I can't see it on the camera frame, but you can hear it click down at the bottom. It locks into position at the bottom of the ramp. I would have one student in charge of getting that out, because it takes a couple of tries to understand how to pull it out, but once you get it, it takes just a second. So having one student do it, they'll be in charge of recollecting the car. You've got your Photogate, and we're going to hook this guy up. It says midway, so you need to unscrew this pretty much all the way out. The direction that you put it in does not matter. I'm gonna put it here on the 60 mark for this. And then you're gonna, of course, connect your cable from there over to your data collector. There we are. And we're gonna hit up CPO timer mode. Now, this first lab is always a good one to start with, because in the instructions, it tells students how they're gonna calculate the speed of the car. I'll go ahead and drop this so that you guys can see. Let's see here. You can see the time, perfect. If I were to do this and I let go, you'll see that I do have a time there. It's a decimal. The further down the ramp my gate is, the shorter that time frame is gonna be, because I'll be going faster. Now, here's the tricky part about how you go from this to speed, because this is just a time. And if you did that first investigation, students learn that that time reflects to how long something is blocking that laser light that's in between the photo gates. And it automatically resets itself, so students don't have to worry about resetting the timer. So that time that you guys had prior, let's put it there, again, 0.0077, all that's measuring, this is called the flag, and you'll see this on the actual investigation sheet. This piece here is the only thing tall enough to actually trip the photo gate, and this is exactly 1 centimeter. So when students go to find the speed of the car, it's speed equals distance over time. The distance that that time was measuring was 1 centimeter, and that's the time. So I would do 1 divided by 0.0077. Initially, your students, at least my students, were confused because they had it backwards, where they thought, well, you divide by 1, it doesn't change the number. But we're doing 1 divided by a decimal, so you'll actually get a bigger number. I don't have my calculator, so I'm not gonna do that calculation for you, but that's how they would get their time. And so that should get students through the majority. It has them move the photo gate at different distances, which should allow them to position of the photo gate, so they'll be measuring at different parts. What they should see, the speed up here, much slower than the speed down here. Pretty simple lab. You'll have them creating a data graph, so making sure that your students know about X, Y, speed versus position, and you got all sorts of questions there. But hopefully this setup helps you better understand how the Photogate, the track system, and all this interact together, especially this 1 centimeter. Doing this lab gives the students that explanation for how they're actually measuring the speed. All right, you'll also be needing a meter stick for this. Most schools have these guys. If you don't have anything, I have a ton of these fold-out meter sticks. They're not as strong, but if you just need to measure something and keep these guys stored away, I do have plenty of those. All right, that's that one. One final note on investigation 1.2. The back page, the very last page, is about analyzing data for error. Unless you've got an advanced class, you might just scrap that last page and that'll shorten up your lab sheet by 1 page. I don't think most students as freshmen need to worry too much about that. But if you got some advanced courses, perhaps that might be something you'd like to do. All right, that is it for that lab.